Hello and welcome to CCMP Switching for Global Insurance Network project that has been planned and implemented by me, Hamza Khalid Ali Sanad Bheza, and my ID is 2017-01064, and this project has been supervised by Mr. Amar Fayyad. In the beginning, Global Insurance Services (GIS) is a company that provides a wide variety of insurance services to individuals and companies. They are planning to expand their services to cover 7 countries: Bahrain, UAE, Canada, China, South Africa, Switzerland, and France, to cover all over the globe. Therefore, they are planning to create a network that connects their departments all over the globe. And the upcoming slide of the project are going to illustrate the requirements and technologies that has been used in the project. The aim of Global Insurance Services project is to produce a network that ensures security, redundancy, and reliability of the network to deliver an expected and high-quality outcome that supports GIS vision. To implement this project, GIS has required several technologies to be implemented on the project. As a result, they have been separated to functional requirement and non-functional requirement. The functional requirements are the major requirements that are the base of the system. Like cannot without them the system cannot be functional, and the non-functional requirements are the optional requirements that will enhance the security and redundancy measures along with improving the performance on the network. Continuing the aim and requirement section, the functional requirements of the project are providing an end-to-end IP connectivity, providing a reliable interior routing by adding OSPF on the ISP devices, and exterior by implementing the static route on the branches connectivity. The VPN technology to exchange the information through the ISP using MPLS Layer 3 VPN and multi-protocol BGP. VRF, the virtual routing and forwarding to give the branches the network uniqueness and share them through the ISP network securely. Then the hierarchical design to support the redundancy and security measures on the network. A protection layer against the unauthorized access using password on login and passwords for SSH and Telnet users, and encrypt their passwords using security command, and support a different type of network by redistributing the branches routes into the provider to cover the ISP networks. Going to the non-functional requirements in terms of them, the VLAN's creation should be separated to separate the departments on the branch. The network should be easy to troubleshoot. The network should be adapt for future growth by adding a routing protocol that supports IPv6 addresses. It should be easy to manage and provide a secure connection between the ISP and the branches using a security features on the routing protocols. Improving the performance also is a requirement. Finally, monitoring the traffic using a known software such as Wireshark. Technologies used on the project include 6 programs. First, GNS3 emulator that has been used to implement the network project since it's an emulator that provides emulation and simulation capabilities. It has been chosen over EvenG because of its simpling installation process, better support in case of troubleshooting, and the device's images are easy to install on GNS3 against EvenG. And Packet Tracer that is provided by Cisco, it has been used to design the initial design because it has the needed network devices to showcase the networks and how it's going to be simulated. There are many alternatives that can be used online, like the diagrams available online, but the best option was Packet Tracer because of the devices available there. And me and my supervisor, we are used to it. Then we have the system design has been done using Enterprise Architect that provide a variety diagrams that support IT division, such as use case, deployment, and sequence diagram that has been used to design the project in case of software that allows me to save my work and continue later. That's what the advantage of Enterprise Architect against the websites or the online diagrams. Just you have one time to save it and there is no device saving. Going to the documentation of the project, furthermore, we have the documentation of the project was done by the 3 main Microsoft programs, Excel, Word, and Project. The Excel, it was published the cost benefit of the project to find the payback period to gain the profits. Also, it's used to generate the reports in terms of budgeting and used to create the VLSM of my IP addressing scheme for this project, and MS Word that provides the documentation for the 3 phases. planning, implementation, and documentation of the thesis document or the whole project because of the suitable features that MS project have. MS Word, sorry, have. MS Word was simplified process for documenting all the steps of the project using the multiple options of text and pictures. And finally, we have the MS project that has plays a huge role in creating the work breakdown structure of the project that illustrate the timeline, generating reports to clarify the cost and time management, and ease the process of planning the project. These three programs provide Microsoft when choosing. Have chosen them because they are supported by Bahrain Polytechnic and I have been using them over my studies. Since I'm near one, I am using them. This as a reason, also additional. I have chosen this program because they provide the basic and the advanced features to enhance the user experience. This section illustrates the network design of Global Insurance Services project. This network has been designed based on hierarchical design to ensure security and redundancy measurements. The blue rectangle in the middle shows the ISP network that consists of 7 devices, 4 as a provider devices, and the 3 are provider edge devices called PEs. As a notice, the yellow area in the ISP network is the MPLS layer 3 VPN done using multi-protocol BGP that acts as a virtual route or virtual route between the PE devices. As a redundancy measurement, each ISP device is connected to minimum 2 devices to prevent failover scenarios, enhancing performance and increasing the security among the ISP network. Also, the connection between the PE routers to branches done using 2 cables to give similar effect as ISP devices gets in case of increasing the performance and failover scenarios. Next, we have the green and orange areas. They are the branches of the networks, and the green one means the VRF customer A networks, and the orange belongs to VRF customer B. And VRF used to configure multiple routing instances in one router, and that give us the option to keep the customer traffic separated from other customers. And finally, the VPCs, the virtual personal computers, on each branch acts as a department to showcase the branch local area network and verify the connectivity for internal department and external departments. Features for this project has been separated to 2 features, the routing and security features. First, we have the routing feature that include the OSPF version 3 and BGP on the OSP devices, OSPF version 2 for the connection between the branches and provider edge, static route between the branches and provider edge as a redundancy measure, and OSPF version 2 for the branches internally. Next, we have the security features that include MPLS version 3 VPN on the PE devices to exchange their route securely, and securing BGP, OSPF 3 and OSPF version 2 with message digest MD5, then creating usernames for and password for the SSH and Telnet users. Then we have to create the password for devices login and IP route to permit the needed routes only. And finally, all the password used above has been encrypted. And next, we have to illustrate the project element using GNS3 software. This is the live demo of GNS3 for GIS networking project. The blue area here will illustrate the ISP network, and the yellow area will illustrate the multi-protocol BGP for each PE router here. And the green and orange are the branches. To begin, we log in to the PE1 device that belongs to ISP and connects the branches. We click enter, we put the password. As it's written, all the passwords are Cisco. Then we have to verify using show run. What we have here, the whole configurations, just to verify this is the wanted router. Now I have to check the telnet connection. Telnet 10.0.0.2. Dot 2 is the loopback of the ISP2 device in the same area. Just enter as a password as a security again. Now we are in privilege exe mode, so just enable again a password for going to configuration. Now we are gaining access to ISP2. Just show IP route. That will show us the routes that ISP2 has from the PE1. If you want to exit, just exit. And here we go. It's closed. And now we are in PE1 device. Now we are going to show you the OSPF v3 that is configured on the ISP network. First of all, the show run. Just going to show it. This are the area in the show run. What does area 1 mean? Area 1 mean it's the all ISP are under one area having an authentication on IPsec that are done using MD5 message digest. This is hashed password. This is the hash of Cisco password. And as we can see, the message digest are for only internal use. So we go to a port that have OSPF v3. It's area 1. This is protected Ethernet 1 in the same area. So as we want to verify it, we can go to show OSPF neighbors. And we can go also with the command show OSPF v3 interface. As we can see now, we have verified the OSPF. And here I have the iPad to know the sequence of the IDs. Now I have verified them. As we can see, as an example, first Ethernet 10 is it has the router ID 1003, and we can see the MD5 authentication is up. As we can see, the word is here. Now I'm going to show you the BGP. Okay, the BGP has been done here. Show run. We can do a section BGP 65000 that will show us the BGP configuration. Now show BGP VPN for unicast, and we can do the VRF because we can do them all unicast. Now what we have advertised here are the VPN for all the routes from the VRFs, and as we can see, we can separate them by VRF customer B. These are the routes from customer A side, and these are for customer B. We can now verify them. The BGP for the internal use, show BGP, show IP BGP, summary. These are the loopbacks of the ISP network. Next, what we have? Next, I'm going to show you the MPLS configuration. Show run. Without show run, I can show you in the show run normally. What each device need to use the MPLS is this command. Show MPLS LDP router ID loopback force. This what it will do. It will force the router ID to be as same as the loopback. So as we can see now, show MPLS LDP neighbors. This shows all the neighbors of the two connections here from PE1 going to ISP1 and going to ISP2. And these configurations are applied for the whole ISP devices. Now if we want to see the discovery, just we click disk. That will show us the discovery between, it shows that ISP1 and ISP3 are advertised, and we can see also the bindings. This shows us all the IP addresses advertised by MPLS. We can see also the MPLS IPs, the interfaces, like int. Just as we can see here, we have the 1 and 3 used as an MPLS. Now, if you want to use the MPLS, you should do a multi-protocol BGP. Like I'm going to use the show run. In show run, as we can see on the BGP section, we need to do this commands on BGP. This will tell the BGP handle the MPLS using these addresses only. These addresses only for our PEs, like PE2 here. As we can see, loopback 4, and down it will be a loopback 7. send community to send it over the network. And now the VRF show run again. Sorry for show running, but for explaining purposes. We have to configure the VRF customer A and customer B. Customer A will handle this the route distinguisher to give the routing table uniqueness. So we have to configure it first, then the route target to share it over the network. If we want to share it over PE, we can, or provider X, we have to configure these two parameters for customer A and B, and first RD for uniqueness and RT for sharing the route target. We can verify them also by show VRF brief. That will give us the brief of the interfaces of them. And we can, if you want to ping it, just we can do, let's ping to loopback of Bahrain at 0.1. It won't ping because it's not in the global routing table. We can cancel this ping. We can do a ping VRF customer A 172.168.0.1. Here we go. We can ping it, we can trace it, we can get access into the branch. As we can ping also for UAE, just change the 6 with a 7. But it has the the same one. So it's the same. We can go to 16 dot, sorry, 17, choosing customer B. Here we go, sorry for this time. And next what we have? We have the connection between these two. This connection are one for OSPF and the second one for static. As we want to verify them. How we verify them? First, by show run, we can know that one of them is connected using OSPF area 0. It's the 00. The fast Ethernet 00 is going using the VR forwarding customer A that will ensure that it's added to routing the customer A route table of VRF. It has been hashed by the MD5 message digest. This is the hash of Cisco. And we can do them in two areas. OSPF 2 will go to customer A and OSPF 3, as we can see here, it goes to the VRF customer B, it's UAE. Then we can also done the static by we can verify the static also. Just verify the OSPF first, OSPF neighbors. As we can see, we have two neighbors. That one goes to UAE and the other one will go to Bahrain. Any 1716 will go on the green side. Okay, this is the verification of OSPF. Let's verify the static. Show. Let's go to show IP static. It will be more efficient. Show IP static, forward, ref, and we can go to customer A. We can now the letter A on every address here, it means it's activate. Let's go to B. We have verified also. Now what we need to do, what I need to do is to have an internal ping for these devices. Since I need to verify them, I will use traceroute to verify the idea. Any ping will go from the insider, which is going to be used by OSPF B3, not BGP. BGP has been used only for exchanging multi-protocol BGP routes. Let's trace route, and we need to ping for the other PE as is it's the loop back of him. Let's see, let's exchange the MPLS, and there is 3 entries here. The 3 entries are showing the possible routes can go from the other side. And as a reason, later I have, or previously I have illustrates the VR of B and A. But I will, later on, I will show you why I have separated them. Okay, and we have verified them. Now what we have to do, let's trace again. 72, it's a direct connection to ISP1, this connection. Dot 1. It will go directly on the connected ports. As we finish from the PE, we can exit. It's a security and feature. You have to exit every time to prevent any unauthorized access. Going to Bahrain management device. We go to console. We show how do we show the IP? Show IP. I have configured this previously. The gateway is available on Bahrain core router. If I want to verify the pinging to my gateway, I have to just type my gateway. I have it now. Now, how I add an IP? I go to my VPC, a virtual PC computer. As we can see, there is no IP configured, just IP 172.168.20.2. 2 is a usable. 255.255.255.248. I have used the VLSM for this branch. 20.11 is the gateway. It's checking now the duplication of addresses, verifying by pinging the gateway. We can check the internal ping. We can just change this to 1, change this to 2. This is the internal pinging. How do I verify it goes outside? I should click trace. It means trace route 172.168.11.2. This device is on Switzerland. It's this device. Just enter. As we can see, everything is going successfully. And we can check also by pinging it 172.168.11.2. It goes smoothly, securely, without any issues. Now going to verification of this route. This route is redundant. It has been done on all the branches. This one is static and one using OSPF. Now if I want to exchange the routes, this is China. We can go to console. Just a verification if there is an IP. There is an IP. We can check the ping 172 as the same IP as previously. It goes on a ping. And this done using the static route is done here. The suspended or the paused connection was the connection of OSPF. As we can go to the PE3 router. We can verify it, show IP route. There isn't any. So what we can do a ping, or we can go to China. We can check it in China. China's more clear. We can go to console. Just the security measure. Let's go. Show IP route. Now it's clear. See? This IP is there connected only for the statically. This, as you can see, the network, and this is the IP. So normally we just ping it to verify if it's functional, and the other, it's possibly not. As we can see, it's suspended. We just need to close it. Now I want to verify one other thing. Here we can go to UAE. We can ping it to Canada. Just I have to verify if there is an IP first. There is pinging 7217. See, as we can see, 17 going for Canada IT branch, as I have illustrated. 22.2. Let's make it again to make the picture clearer. And the reason why separating VRF, because VRF giving the opportunity to separate the routes or routes on each PE router. Each PE can separate the routes. The solution to make the UAE connecting to Bahrain is leaking route, but I didn't do it. As we can go to VPC to verify there is no connection between UAE and Bahrain. Show IP. Sorry for these verifications, but I need to do it. You can go to 172.110.1 destination host unreachable, because there is no leaking route between VRFs, to just show how each router or PE is separating the routes insidely. And this was my GNS3 network. I have done it with the all required features, and if there is any notes or issues, just let me know to know my mistakes. Thank you. Bahraini perspective, this project has been implemented by a Bahraini citizen and supporting Bahrain economic vision of 2030, and can be used for small and big businesses to take this project as an example to start their bigger networks in Bahrain. After that, we have the legal, ethical, social, and professional issues that consider to prevent any future problems. Legally, I'm legally bound to not reveal or disclose any sensitive and privileged information during the implementation, and ethically, the naming scheme must be suitable for each device and not every information done in detail. Socially, the project must bring a positive elements through enhancing performance, securing the connection between channels, and professionally, while producing the project, all the stakeholders or the people should be treated with respect and politeness in all phases of the project, and these issues must adhere Bahrain policies and procedures. The future work of this project include VRF-aware dynamic VPN, Flex VPN, group encrypted transport VPN, voice over IP, ACL to control the traffic, demilitarized areas, a wireless router, remote users using EVNG software, adding 5G technologies, usage of network automation, hot standby router protocol, and cloud computing. And these technologies are going to enhance the network strength and bring better experience for the users. I sincerely appreciate your interest in my presentation. If there is any question appears, feel free to ask me. Thank you very much and have a nice day.